So this is the atomic absorption spectrophotometer, and the way this works is we have a hollowed cathode lamp here, and you can adjust the amps by turning this knob right here. We then have a flame which I've already lit, which is right in here, and so the light from the hollowed cathode lamp goes through the flame, and then the detector is this over here. Your sample will be pulled up with this straw and will go into the flame and atomize the sample, and so the light will go through and be absorbed by the atoms in the flame. So the first thing you have to do is make sure that you have the correct lamp in position. There's multiple lamps in here, and so this lamp that's in here is for lead, but you can also have other lamps depending upon what lamp you want to use. There's drawers here that you can use the different lamps depending upon the element that you want to detect. Before you actually start the instrument, make sure you have a beaker filled with 18 mega ohm water. And if you come over here to this side, there is a little float in here, and you need to make sure that this is filled so that when the water goes, when it travels up this sample tube, the waste will go through here and then come down in here to the waste container. So you want to make sure that this waste container is actually going into that container right here. You also need to make sure that you start the computer and you click on the software so that this can record the data that you record with this instrument right here. Next, you need to turn on the instrument. You hit the red power button, and I've already turned it on, but when you hit this on, the instrument will start up. In order to figure out the conditions that you need for the experiment, you can hit the buttons here to figure this out. So if you hit the mode button, you can then select different elements of, so if you hit 1 and you hit enter, you get a choice of a variety of different elements. We want lead, which is PB or 82, so I'll type in 82 and hit enter. And so I have element being lead, and then the optics is atomic absorption, double beam. The statistics, we're going to be collecting five data collections and then averaging. And so this gives us the different information. So you can, to get back to the main screen, you can hit enter. Once you're here, if you hit the recall button, we can set up or we can determine the flame conditions that we have for lead. And so it says 2, so I click on 2 and hit enter. And I want the flame conditions for lead, so again I hit 82 and hit enter. And so here we have the flame conditions for lead. So the element is lead, which is atomic number of 82. HCl is hollowed cathode lamp, so it's set to 5 milliamps. We have an air acetylene flame, which I'll show you in a little bit, but we have air and acetylene, which is our fuel and oxidant for the flame. And then it gives you a list of 3 different wavelengths that you can use to set it. And so typically we'll be using 217, and so this is the wavelength knob. And if you look closely, you can see that it says 217 on here. And you can adjust the wavelength knob by turning this right here. Another place where it says the wavelength is if you open this up, there's a card here, and for lead, where's PB? It says, where'd it go? There, 217. So you have 2 different sources that tell you what the wavelength is supposed to be. So the 5 milliamps, we need to set this to 5 milliamps, and so if you open this up, I told you before that you can change the intensity using this knob right here, and so you adjust this knob until we have a current at 5. Next we need to adjust the voltage, and so this knob right here is the voltage. Typically when you get the instrument, it'll be set to its lowest value. You want to increase this until the marker is just at the bottom of the green, or just above the 1 condition right there. The instrument is now set up, and so now we can turn on the air and the fuel to start the flame. Even though the flame's already started, I will show you how to go about doing that. So if you come here behind the instrument, you turn the air on by adjusting this. It's already on. If it was in a closed position, it would be up in this position right here, 90 degrees to the pipe. And then here we have our acetylene tank, and I've turned the knob on to turn the acetylene so the acetylene can go into the instrument. Basically, one thing you need to be aware of is if this arrow goes below the red 150, we probably need to change the tank, because then we're getting too much acetone in the flame, and that's going to adjust the flame condition. Off, we turn it from off to air fuel, and then to start the flame, if you see here, you hit the pilot button, there'll be a pilot light that lights the flame. So once you've started the flame, make sure that the straw is in the water, and now we have the flame going and the instrument's ready to set. You should let this warm up for 20 to 30 minutes before collecting data so that the flame can stabilize and you can get consistent results. So, to collect data, we have to get back to the main screen. We hit enter, and then in order to collect data, all we do is we hit the read button, and if you look, it will record absorbance measurements, and it'll record 5, and then at the end it will give you the average and the standard deviation of that value. So it gives you the mean, standard deviation, and relative standard deviation. We also have the computer set up. If you set up this correctly and you hit enter after hitting read, it usually collects data. In this case, it froze, and so you need to open this up again, open the software up so that you can record the values recorded by the instrument, and they'll be printed off on the paper. So in this drawer right here, we have the standards, and so we've got 0, 1, 3, 5, 10, 15, 20, 25. There's also a 7 in there, which is out of place, and then 30 and 40. Basically what you're going to do is you're going to run each of your standards, you're going to run your samples, and then you're going to run your standards again, so that your samples are sandwiched between standards both before and after. And you need to check to make sure that the standards are consistent both before and after, and if they're not consistent, you'll run your samples again, and then your standards again, so that you want to make sure that your standards are consistent both before and after your sample in case the instrument drifts. Again, another reason why we let it warm up 20 minutes, and so hopefully that drifting will not occur.